Today I'm going to be doing some welding on my anvil to correct the problems that I discussed in my last video. Now, I'm not a really good welder, I have to say right up front. I do understand the principles of what it takes to make a good weld. It's just a crapshoot as to whether I can get it done or not. And the main reason for that is I just don't weld enough. If I go through 5 pounds of rod a year, that's a pretty hectic year for me. So my experience welding is basically putting together jigs and the tools that I need around the shop. The reason welding this anvil is so different than, say, just doing a fillet weld or any other welding joint is that you need to lay down a layer of metal so that when you grind that layer down, there aren't any voids or slag pockets or any irregularities that are going to cause problems. And that takes a lot of experience and a lot of time. I spent 5 hours welding on this anvil, and I thought I had all the areas that I needed built up enough, but when I started to grind through, I found several areas that I missed. I managed to get the anvil where I needed it to be, but you can tell that it wasn't a professional welder that did this job. And I'll be real happy when the anvil starts to rust up again and everything becomes a little more blended. So this video is more about how to approach the problem rather than how to do the actual welding. For the last minute or so, you've been watching the clip of me preheating this anvil. And in my opinion, properly preheating the anvil is probably the most important step to getting your welds to stick. If you start welding on a cold anvil, the heat from the weld is going to get sucked into the body of the anvil, and the welds are going to cool too quickly and they're going to become brittle. Also, you don't get the penetration that you need to make a good weld because the arc can't heat up the metal around it fast enough. So while I'm waiting for the anvil to heat up, I'm going to take a few minutes to work out exactly what I need to do to straighten out this face. Now I'm prepping the area by grinding away as much of the rust as I can. As I'm grinding, I'm finding a lot of cracks and crevices from other repairs, so I need to grind through those to get to solid metal. After about 2 hours with the burner pointed at the base of the anvil, the heat had traveled through enough and everything on the anvil was warm, right up to the tip of the horn. So I moved the burner around and concentrated it on the face. This clip was taken about 45 minutes after I moved the burner around to the face, and you can see how the heat is traveling nicely right through to the middle of the anvil. So this entire clip represents about 4 hours of preheating. But that's how long it takes to build up a good bank of heat in that anvil. So now I can start welding without worrying about the welds becoming brittle. They're still going to look ugly, but they're going to stick, and I'll be able to build up a good forging surface with it. If you're not familiar with all those center punch marks on the side of the anvil, this anvil at some point was used to repair logging equipment, and they would drive a PV into the side of the anvil to set the point into the handle. This is a wrought iron anvil. It may have had a steel face on it at one time, but it's long gone. I would estimate that there's no more than 10% of it left. So this is basically a soft anvil, so I'm not concerned about losing the heat treat here. If you're working on a steel anvil with a hardened face, then this would definitely remove any heat treating that it would have, so you'd have to carefully consider that before you proceed. If you want to maintain that hardened face, welding on an anvil is definitely the last thing you should be doing to it. The accepted practice for building up a surface is to lay a series of overlapping beads going in one direction and then start laying beads 90 degrees to that so they cross over each other, and theoretically that takes care of all the voids and all the imperfections. But as I mentioned earlier, it's really hard to get that right. In hindsight, what I should have done was I should have ground each layer down as I was building it up. So in other words, if I was laying a series of beads along the length of the anvil, I should have ground that whole layer down, see where the imperfections were, fill that layer with more weld, and then grind that until I had a smooth surface, and then continue from there, because I just didn't have the experience to build up several layers 90 degrees to each other and come up with a solid surface. So here I decided that I was going to need to grind away too much material to create a smooth surface, and I had to settle with a surface that was level even though there were depressions in that level surface. Fortunately, I didn't have to do as much welding on the face, so I was able to do a better job with that. I'm doing most of the welding with 6011, and I'll be following that up with 7018 AC to do any cleanup. 7018 is designed to leave most of the metal on the surface, so it's great for infilling and, leveling out pockets. So the last 5 minutes represents about 10 hours of work, and I really should have planned this over a 2-day period because I realized that there's just so much more welding that I needed to do, and I just didn't have enough time to do it. So this is the next day, and I've done a rough grind on the surface of the anvil to take it down to a fairly level surface. There are still a couple of divots that I wasn't able to grind smooth because I didn't build up enough filler rod there, but I'm not going to worry about it. It's not going to affect any of the work that I'm doing. So now I need to go over the whole surface very carefully and grind in the work surfaces that I need. As you can see, this area of the anvil is still a little bit crowned, and this is where I wanted to have a perfectly flat surface. So I'm going to start by working on the center section of the anvil. I want a strip that runs right through the whole center of the anvil to be perfectly flat. And I'll just keep working at that until I take the crown out of the anvil and I can create the other square and flat area that I need. So for this part of the process, I've switched over to a flap wheel. This sanding disc will remove enough material to get the job done, but I'll still be able to go slow enough that I can fine-tune the areas that I need to. So the key here is to really take your time. Take a few light passes, check it with the square, and then take a few more passes, check it again. In the early stages, you're trying to develop a really good understanding of how much material is coming off with each pass so that you can estimate how much you need to do to get the results that you're looking for. Once I get that center section trued up and down far enough, I'm going to start working very slowly to get rid of the raised areas that are on either side of that center section and the edges of the anvil. But the process remains exactly the same. You do a little bit of work, check it with your straight edges in every direction to make sure that you're not going off course, and then do a little bit more, recheck that with your straight edge, and so on as many times as you need to get the surface that you want. And the final step is to sand in the large radiuses that I need at the front of the anvil. I decided the only thing I was going to do with the horn was take off some of the raised section right at the very tip and profile it a little bit so it's a little more usable. Sometimes when you've been doing a lot of grinding on a surface, it's hard to tell where you are, so I'm using this random orbital sander with a 60 grit paper just to create a different texture on the surface, and that'll really highlight the areas that need more work. So here's the finished anvil, and even though there's a lot of room for improvement, I'm really happy with the overall results. I managed to get that curve out of the front edge of the anvil. Also, the back corner of the anvil is now square, and the face is now square with the body of the anvil. I now have a section of the anvil that I can use for more specialized forgings when I need a very flat surface, and the front of the anvil is where I have the larger radiuses, where I do most of my forging. Again, my decision to weld on this anvil was because there was absolutely no other way to repair this anvil and make it usable. So the decision to weld on it was pretty straightforward. In the next video, I'll be going into this a little further and certainly discussing everything that I know about anvils, and hopefully that'll give you a little more information to make a decision about how you want to repair your anvil. Hi, I'm Dennis, and thanks for watching. If you liked this video, by all means give it a thumbs up. If you want to support this channel, you have a couple of options to do that. The first, of course, is to just subscribe. Secondly, if you have any suggestions or photographs of things you'd like to see on this channel, send them along and I'll do my best to turn them into a video. If you want to lend your financial support, you can do that in a couple of ways. First, if you're interested in making an ongoing contribution to this channel, just click the Patreon icon and it'll take you to my Patreon page, and you can donate whatever amount you feel comfortable with. If you want to make a one-time contribution, just go to my channel homepage and click the donate button in the banner. So thank you for your support, and with your help I'll be doing this for some time to come. I'll see you next time.